let us use the limit definition of the derivative to find the derivative at 0. And so first off, we will recall that f prime at a point is given by the limit as this small increment goes very, very small of varying the function by a very small amount over the displacement that has happened, which is x plus h minus x plus h. So it's just a slope. These are the y points, these are the x points, but I simplified it. y2 minus y1 divided by x2 minus x1. Okay, now if this limit at 0 exists, so if the derivative exists, then this function should be should have only one derivative. So and notice that this is a piecewise function. So at 0 there are two different definitions. So there is 0 minus, which is 0 that is less than 0, very small values, and there is 0 positive, which are values which are greater than 0 by a small amount. So in that case, we need to consider f prime of 0 positive. Maybe I'll say f positive of 0 prime and f negative of 0 prime. And I'll write it as follows. Here I put a minus, here I'll put a plus. This will be a limit h goes to 0 positive, and this will be h going to 0 negative. Then 0 plus h is just f of h, and then f of 0, and then we're dividing by h. Now, if h is going to 0 positive, so it's greater than 0, and then in that case, in the first case, f of h will be precisely a minus, no, not minus, it's positive, so this is the positive part. So it will be sine of h. So f of h will be a sine of h. And then we take away f of 0. F of 0 is actually 0. Precisely at 0, this function is defined to be 0. So it's fine if we write 0 here and 0 there. But, I mean, we're just taking away 0, so we might as well remove it. Now we're looking at f of h divided by h. Here it's sine of h divided by h, and the limit is going to 0. Maybe that reminds you of something. I don't know. In the meantime, if you still haven't recalled this, I will substitute the appropriate function for the lower derivative, or the minus derivative. And notice that if x is less than 0, or actually in that case h is less than 0, then we have minus x squared. Well, not x actually, in that case it will be minus h squared. Then it's minus h squared divided by h. Then now we can simplify or take the limit. So we simplify and take the limit. H squared goes away with h, you have minus h, and if you plug in 0, you get 0. But sine of h over h is 1. We've done this multiple times. We've improved it using trigonometric identities and the squeeze theorem. then now we're confused because we are at 0. We don't know what the rate of change at 0 is. Is it 0 or is it 1? We don't know. That's the problem. And since this is a problem we always face, then in that case, this is not, the derivative is not defined. So a derivative, f prime of 0, is a function that takes one input and should return to me one output. So it cannot return to me 1 and 0. It returns to me one output, then there is an error with this construction, and therefore there is no f prime of 0. Because f prime of 0 should give me one number, but it gives me 2. So there must be no derivative at 0 for this function. And as a general theme, you should always check this when dealing with composite functions. No, not composite, piecewise, when dealing with piecewise functions. That is a general theme and a general thing to look out for. Usually you want to check continuity at the points and continuity at the derivatives. Here continuity at the points is fine because sine of 0 is 0 and 0 is 0 and minus 0 squared is 0. So it is continuous. I can draw it without lifting the pen. Everything is nicely defined at 0. But if I take the derivative, then I get two very different slopes. And that's why this is, we cannot assign it a certain slope. You get two answers, then there's no answer. And that's how you do it.